What did the acorn say when it grew up? Gee, I'm a tree. Welcome to National Nut Day.
What?
People out there.
Wait, restart it?
Geometry.
It'd be funny if we were in geometry. But we're not in geometry.
I see.
Wait, why would it be funny for geometry? Because G.
Let's continue with the lesson.
My life is a lie.
All right, so we have
This is bad.
this particular drawing, and we're looking at degrees and radians as a review. First, I'm going to draw in the degrees. And then I'm going to look at the radians. We're going to remember the definition of a radian, or definition of radian. The radian is equal to the arc length divided by the radius. If I were to think about one revolution, one way around the circle, it would be 2 pi r, r is 1, so it would really be 2 pi divided by my radius, which would be 1. So it would be 2 pi divided by 1, which is equal to 2 pi. All the way around, I know in terms of radians, it's going to be 2 pi radians. And then I could just divide it into quarters to get my other numbers. So this could be pi over 2, pi, 3 pi over 2. Adding pi over 2 units each time as you go along. Also, with reference angles, I've noticed with degrees, I have 3 reference angles as I go through: 30 degrees, 45, and 60. When I think about my radians for each of those reference angles, I can now think about it instead of converting. So if I took, for example, 60 degrees down here, and I wanted to convert that to radians, I would do pi over 180, and I would see that that's equal to pi over 3. So 60 degrees is pi over 3. Similarly, you have pi over 4 and pi over 6. Those are your radian reference angles that you can use in drawing in any angle. One more idea on this is the fact that what you can change pi and 2 pi into fractions where you can add these reference angles. But in order to do that, you need denominators that are the same. So that's why we're also going to think 1 pi is the same thing as 3 pi over 3, 4 pi over 4, and 6 pi over 6. And so I can easily add any of these to any of these reference angles to those angles. And the same thing for 2 pi, I can write it as 6 pi over 3, 8 pi over 4, and 12 pi over 6. Again, adding and subtracting reference angles from those. Let's go ahead and do some problems. We're going to do the second day on radians. First day was what's a radian, how do you draw it in, how do you convert between the two. The second day, which is today, is going to be only focus on the radian measures. Some of it is slightly conversion, but then the second part, which is going to take some time, is going to be on only dealing with radians and reference angles. Notice on your homework I did change it on Thursday in case you missed that. There is a section there that I added just odds, and that's going to cut down your homework substantially. So that takes a long time on that lesson. Draw, convert, and find both reference angle of 120 degrees. both reference angles, meaning degrees and radians. So this is still a conversion type of problem. The next one's not going to be. Let's go ahead and do this. The first thing I want to do is draw it. So I'm only thinking about 120 degrees. 120 degrees. Find the reference angle to 120. That's going to be 60 degrees. And then I have to convert both of them. So what I could do is I could say 60 degrees times pi over 180 to convert. And you're going to see that that is going to equal pi over 3. So my reference angle is really pi over 3 or 60 degrees. And then what I could do is I would automatically know what 120 degrees is. I could say if this is pi, pi minus the pi over 3 is equal to the rest of that angle, which is actually 2 pi over 3. So you could actually save a lot of work there and say that that's just going to be 2 pi over 3 because pi minus pi over 3 is 2 pi over 3 and I'm done. If you don't like that, you could go over here and say, all right, 120 times pi over 180, really twice the amount of what we did above here, because it's 120 instead of 60. So it's at 2 pi over 3. And that's it for those type of problems. The second type of problem, however, is going to take a little bit longer, and it involves finding points to an equation. If I look at this problem, and I say, you know what, for number 70, I'm just going to add y equals 4 cosine of 3x plus pi over 6. Remember, this is 1 unit. I cannot separate that, and it's 4 times that number. And then what we want to do is actually substitute all these values in for x and get my y's. And what I'm really doing is finding points on the equation for y equals 4 cosine 3x plus pi over 6. Why am I finding these points? Because next chapter we will start drawing graphs of all the trig functions and inverses. So that's a big chapter. All right, so this is just the beginning of it. And so what I want to do is stay nice and organized in a problem like this, or else you're going to have a ton of work all over the place. So what I want to do is form a nice big table. And I'm going to show that I have my x, and I'm going to have some work, which is going to be my 4 cosine of 3x plus pi over 6. And then I'm going to get my y, and then I'm going to have an ordered pair x, y. Normally when you found ordered pairs, they're like 1, 2, -5, 7 points. But now we're going to get into different x's, which are in these radian modes. Not once do I change anything in terms of degrees. It's all radians. If you keep it in radian mode, these problems become peanuts compared to being so hard when you keep flipping them around so much. So let's go to the first one. We're going to start with 0. 0 becomes the easiest problem. If we plug 0 in for x, I'm going to have 4 times cosine 3 times 0 is 0 plus pi over 6 is just pi over 6. I know that the cosine of pi over 6 now by my table is just going to be radical 3 over 2. Now the way that I think of that is not going to my table, but I think sine of pi over 6 is 1/2. The cosine has to be that other number, radical 3 over 2. So So this becomes 4 times radical 3 over 2. That's a substitution there. And so my y here is going to be 2 square roots of 3. Therefore, my xy is 0, 2 square roots of 3. Let's go to pi over 6. What's my number? 4 cosine, and now it's going to be pi over 6 in for my x, which really means this is going to be 3 pi over 6 plus pi over 6. I kept it, I want to keep it with the 6 in the bottom so I can add those fractions. Now it becomes 4 pi over 6, which is the same thing as 4 cosine. Let's see, 4 pi over 6 is the same thing as 2 pi over 3 when you simplify the 4/6. Now I have a problem within a problem because I need to know what the cosine of 2 pi over 3 is. So if I were to draw this, let's see now, 2 pi over 3, it's got to be right here at 2 pi over 3, meaning the reference angle is going to be pi over 3. Cosine of pi over 3, but I've got to also remember from Santa Claus, that's an s there, so it's negative cosine of pi over 3 is the same thing as negative 1/2. Cosine pi over 3, I know that the cosine pi over 6 is radical 3 over 2, so 1/2 comes down the other way. Okay, so that becomes equals 4 times negative 1/2, which is equal to negative 2. There's a lot of room to make a mistake on these types of problems. Adding fractions, finding reference angles, negatives. 1 point off and your graph is going to be off as well. So you really have to be careful with the details here. 0. 4 cosine pi over. Thank you. Let's go to the next one, which is pi over 3. Pi over 3. So let's go 4 cosine 3 times pi over 3 is just pi. So it becomes pi plus pi over 6. Now this is 4 cosine 6 pi over 6 plus pi over 6, 7 pi over 6. I'm going to head and graph this. This is where my reference angle is pi over 6, which means it's the same thing. Cosine 7 pi over 6 is the same thing as negative cosine pi over 6, which is this negative radical 3 over 2 by the table as well. And now what I'm going to do is write down 4 times negative radical 3 over 2, which means that this is going to be pi over 3 negative radical 3. Sorry, it's going to be pi over 3, and then it's going to be negative 2 square roots of 3. Because the 2 goes into the 4 2 times, 2 times negative radical 3, negative 2. Last one, pi over 2. Well, this becomes 4 cosine 3 pi over 2 plus pi over 6. So I have to somehow be able to add those fractions. And now, let's see, I've got to do common denominators. So 4 cosine, this is going to be 9 pi over 6 plus 1 pi over 6 is 10 pi over 6, which is the same thing as 4 cosine 5 pi over 3 4 cosine 5 pi over 3. We're going to go to the other sheet and find out what that is. Cosine 5 pi over 3. This is the same thing as 6 pi over 3. 3 pi over 3, it's closer here. So I'm going to do this. It leaves pi over 3. It's pi over 3 more to get to 6 pi over 3. So this becomes, and it's positive because cosine is positive there, so it's cosine pi over 3 is the same thing as the cosine of 5 pi over 3. Cosine of pi over 3 on your table is going to be 1/2. Going back to this is 4 times 1/2, which equals 2, and that gives me my last point. A lot of writing on these problems, a lot of graphs, a lot of room for mistakes. Please be careful on doing these problems. Think radians. Don't grab your calculators to add fractions. I'm not going to let you use calculators on the test. You've got to be able to add fractions, get those common denominators, and take the time on these. Have nice drawings on the side. Hope you have a wonderful nut day, and